Welcome back. This is an Aleks training video on finding a molecular formula from molar mass and elemental analysis. In a previous topic, we looked at elemental analysis, which was the longest of all of the lessons we've looked at this year so far, and lots of steps. We found out that we could find an empirical formula, and an empirical formula is the smallest ratio of elements to each other. Okay, let me give you an example of a. They're asking here for the molecular formula. Let me give you an example of an empirical formula and a molecular formula. Okay, the molecular formula is what the molecule actually is. So, for instance, if we take a molecule of sugar, sucrose, it would be C6H12O6. So if you were to have a molecule of sugar and you break it down to one molecule, find out how many atoms are in each molecule, in one molecule, you would see that in sucrose, sucrose, which is sugar, you're going to have 6 carbons, 12 hydrogens, and 6 oxygens. This is called the molecular formula. Now, the empirical formula, what we found before, is just the ratios. Okay, so could I find a smaller ratio than 6 to 12 to 6? Okay, what number fits in 6s and 12s equally? Well, 6 could go into 12 and 6 could go into itself. So I could say that its empirical formula is CH2O. This is the empirical formula. So an empirical formula is just the ratios, 1 to 2 to 1 in this case. The molecular formula is not just the ratios, but what you actually have in a molecule. Well, when we do this, when we do a percentages, in this case 44.44%, 3.37%, 51.83%, the only thing I can find is its ratios. I know that it's this many carbons to this many hydrogens to this many nitrogens. I can find the empirical. If you're given the molar mass, I can also find its molecular formula, and that's what we're going to do. We're going to add one step. All right, so I'll do this faster than before. I'm going to assume 100 gram sample and then directly make the percentages into grams. So carbon, I'm going to have 44.44 grams of carbon. Hydrogen, I'm going to have 3.73 grams of hydrogen. And nitrogen, I'm going to have 51.83 grams of nitrogen. I'm going to turn it into moles because moles is a number and I can compare numbers to numbers and find ratios. So I divide by the molar mass that I get from the periodic table. So carbon is 12.0107 grams per mole. Hydrogen is 1.00794 grams per mole, and nitrogen is 14.0067 grams per mole. So grams will cancel, grams will cancel, grams will cancel, and then when I divide it out, 1 mole is to 12, 1 mole is to 1 mole is to 14. When I divide this number, I'm going to have moles. Moles is a number, and I can compare number to number and then find a ratio. So I turn my carbon grams into moles of carbon. So I have 44.44 divided by 12.0107, and I have 3.7. Okay. Let's go ahead and do three digits. For hydrogen, 3.73 divided by 1.00794, and I'm going to have 3.70 also. So those will have the same number on my empirical formula. Nitrogen, I have 51.83 divided by 14.0067, and I have 3.70. Ah, that's wonderful. That means it's 1 to 1 to 1. Okay, so I'm going to take these three, C, H, and N, C1, H1, N1, and this is called the empirical formula. Now, they're asking for the molecular formula. What is the formula of the molecule? I don't know, but I am given its molar mass. Okay, so what is the molar mass of my empirical formula? How much does 1 carbon, 1 hydrogen, 1 nitrogen weigh? Let's compare that number to this number. And if it's a multiple, I can find its molecular mass. Watch what I'm going to do. What is the weight of that molecule, the empirical formula? Well, I've got 1 atom of carbon, and it, if I go to carbon, is 12. This is the periodic table again. 12.0107. Okay, so it's 1, so it's 12.0107. I have hydrogen. Again, that's 1. So it's going to be 1.00794, which gives me 1.00794. And the nitrogen, I'm just looking here, is 1 times 14.0067. That gives me 14.0067. Add them together and find out how much the molecule of this empirical formula weighs, and then we'll compare that weight to the weight of the molecule. Okay? How much does the formula mass weigh? So 12.0107 plus 1.00794 plus 14.0067 weighs 27.02534. Okay. Now I want to compare this number, this amount. This is in grams per mole. I'm going to compare this number to this number. Okay. If it's the same number, if they're identical to each other, that means that this formula is also your molecular formula. Okay, your empirical formula could be your molecule. We don't know, but at least it's this, or it's doubled, which would be C2H2N2, or tripled, C3H3N3, quadrupled, or whatever it is. So we're looking for how many times does this go into this number. And that number will be multiplied by each one of these, and that's the molecular formula. So I'm going to take 135.13 and divide it by 27.02534, and I get 5. Okay, 5 is going to be multiplied by each one of these to give me my molecular formula. So I'm going to take this, multiply it by 5. So I have C5, H5, N5, and this is my molecular formula. Okay, remember my molecular formula for sucrose, C6H12O6. My empirical was simply its ratio, 1 to 2 to 1, but I need to know its molar mass in order to be able to find its molecular formula. So this is what it is. You're going to do element analysis up to here. Then find its mass, find the mass of that formula. How much does it weigh? By adding them all up and then dividing it into the molar mass given. Okay? Big, long. I hope you're learning.